Is a beam of light a wave or a succession of particles we call photons? Can it be both? The wave nature of light was demonstrated by Thomas Young in 1801 in the precursor to the double-slit experiment. This view was reinforced in 1865 by Maxwell's prediction that light carries energy in oscillating electric and magnetic fields. A little more than 20 years later, Heinrich Hertz used sparking electric circuits to demonstrate the reality of electromagnetic waves in the radio frequency range. A turning point occurred in 1900 when German physicist Max Planck hypothesized that radiant energy was emitted and absorbed in discrete bundles, each of which he called a quantum. According to Planck, the energy in each energy bundle is proportional to the frequency of radiation. Planck imagined that the energy of matter changes by quantum amounts. He didn't yet see what Einstein saw 5 years later, that light itself comes in quantum bundles, which we now call photons. We've seen this relationship before. When the energy of a photon is divided by its wave frequency, a constant value of 6.6 times 10 to the minus 34th joules seconds occurs. So the proportion becomes where h is called Planck's constant. The equation E equals hf gives the smallest amount of energy that can be converted to light with frequency f. A few words about Planck's constant. Some people find its precise value mysterious, especially since if it were slightly higher or lower, stars wouldn't shine, and there'd be no life as we know it. H is just right for life. But you could say the same about the constant pi for circles. If pi had a different value, we wouldn't have circles? When we look around us and when we measure values of physical constants, of course we see and measure what is conducive to life. We're here. When we examine the properties of circles and flat space, of course we measure pi to be equal to 3.14159 and then some. We view constants as measurements of a nature that exists. Nature determines the constants. The constants don't determine nature. So I don't see a mystery here. Now what is a mystery is why the universe exists. But that's a much bigger question. Interestingly, the equation E equals hf can get personal. It tells us why microwave radiation can't do the damage to molecules in living cells that ultraviolet light and X-rays can do. First of all, when photons interact with atomic particles, they transfer their energy to the material and break chemical bonds. In doing so, they dislodge one or more electrons from an atom in the material, causing ionization. Ionization causes cell damage. Inside every cell is DNA that determines how a cell performs. Damage to DNA is serious and can lead to cancer. The photons that make up mobile phone radiation are only some 4/millionths of an electron volt per photon. The minimum energy to damage DNA is at least 4 electron volts per photon. That corresponds to a radiation frequency of 10 to the 15th hertz, about 1,000,000 times greater than the microwave frequencies of mobile phones. So the radiation associated with cell phones cannot produce the ionization that causes cancer. Why? Electromagnetic radiation interacts with matter only in discrete bundles or photons. So the relatively low frequency of microwaves, about 10 to the 10th hertz, ensures low energy per photon, too low to cause ionization. Likewise for microwave photons from cell phones and Wi-Fi. Nice to know about that. Ultraviolet is 1,000,000 times greater in frequency, 10 to the 16th hertz, and X-rays with 100 times greater frequency, 10 to the 17th hertz. In short, radiation in the microwave region is 1,000,000 times too low in frequency to create mutant strands of DNA. But higher frequency waves are another story. Note in the chart that microwave radiation centers around 10 to the 10th hertz, and ultraviolet is 1,000,000 times more, centering around 10 to the 16th hertz. This means ultraviolet photons, 1,000,000 times higher in frequency than microwave photons, can zap a molecule with 1,000,000 times more energy. X-rays, with still higher frequencies, can deliver even more energy. So in terms of the relatively low operating frequency of mobile phone radiation, if there is harm, look elsewhere than the energy of its photons. So we see that light is emitted as photons, with each photon throbbing at a frequency f and carrying an energy, hf. Low frequency, low energy. Evidence for the particle nature of light, interestingly, the view of light held by Isaac Newton, was convincingly demonstrated in the photoelectric effect, the subject of our next lesson. Then we'll go on to show that beams of electrons, or for that matter, beams of any kind of particles, have wave properties. We'll see that the quantum world is an intriguing place. For now, I want to leave you with a question. How does the equation E equals hf relate to whether radiation from a mobile phone can lead to cancer? Until next time, good energy.